USBs, and now it's working well. Then, we added extended integrations and new hotspot mechanism. The hotspot has been achieved by working together with device drivers and user space program. I will talk about the performance consideration and new hotspot mechanism. Before talking about the change of buffer size, I will briefly describe the relation between ring and ring requests. Look at this figure. Encode ULBs and its buffers are mapped to ring as a ring request and sent to the backend. Size of ring and ring requests are fixed. Ring is a page. And so acceptable ULB buffer size is limited. Ring size is Q depth of the ring, the number of requests of ring. Ring size and ULB buffer size are trade-off. If the buffer size and the pink shaded areas become larger, the number of ring requests and the number of ring requests, the ring size is decreased. So change from first race to second race. Ring size was decreased from 32 to 16. If ring size is decreased, the transferring is likely to become a shortage of ring buffer called ring full condition. How does this affect the performance? Here's the benchmark result. This will show the reading and writing groups of the flash drive, hard disk drive, and solid state drive. Blue bars shows the native drive result. Blue bar shows the PVUSB result with ring size for 16 condition. Green bar shows the native drive result, measured between 0. What a terrible performance. The performance is less than half of the native. What I said, PVUSB achieved a good performance. Is that a lie? No. Show the result with ring size equals 32 condition. The red bars, really good result as same as the first release. Let me summarize the results. Ring size 16 condition significantly degrades the performance. Its performance is about half of ring size 32 condition, and right performance is even worse. We found ring frequency falls into the ring condition and in ring size equals 16 condition. The ULB buffer of 64 size caused considerable performance degradation. 64 buffer is required for Windows guest. Linux guest usually use a much less buffer. For example, this storage driver of the Linux always use 4 KB buffers. That's one page. So it's waste. To improve the performance, multi-page ring and efficient use of ring are needed. At second release, the performance has been degraded temporarily, but we are going to recover it by using NetChannel 2's new ring architecture. However, if you can't wait or you don't like this default value, you can modify it and tune up by yourself. See this table and edit the code directory as you like. I found 10 and 60 is not suitable value. I will now explain the hotspot mechanism. This slide shows the USB driver's implementation and the program that cannot be resolved by driver alone. USB device driver usually registers a list of devices that the driver can access. And the probe function is called when the device is added. USB back must handle any devices. So USB back registers wildcard list. Just magic. According to this, probe function of the USB back is called every time when a device is added. However, there are 3 problems. Probe and disconnect functions are called once when the device is actually connected to the system. connected system. Virtual hot plug cannot be achieved only by the driver. And also, wildcard probe sometimes fails. If two or more devices claim the same device, two or more drivers claim the same device, which will mean depending on the speed core and can't handle it. So real hot plug sometimes fail. Here's the solution for virtual hot plug. The USB device driver has bind and unbind files in CSX3, and you can manually bind and unbind the driver from the device through these CSX files. XM USB attacher and XM USB detacher are implemented as below figures. To connect or disconnect virtually, XM USB attacher and XM USB detacher use this bind and unbind interface. Next is solution for real hot plug. Assistance with UDP Demon and ZenD is necessary for hot plug. When you connect a USB device, that should be claimed by USB bus. Sometimes the device is grabbed by other driver, example USB storage. So we added a new UDP tool for watching USB device connection. And this will send a message to ZenD. ZenD passes the leaving message and unbind the device from other driver. And rebind it to USB back. So USB back can successfully send back the device in this way. Here's to do and feature work. About XM ZenD code, we'll post the experimental version soon. But the first version of XM ZenD has no Zen API support, so we have to add it. And this is between you and me. This is my first Python program, so they have many bugs. About the drivers, I'm now porting the PVUSB to current timing and preparing there. And we have to recover the performance by net and some optimization. And we will support the USB 2.0 webcam. USB 2.0 webcams have not worked yet. The transferring the URL have no errors, but the buffer of the PDF for Linux are not created. Maybe I think it's a message or other kind of issue, and I'm going to analyze details. After I finish about to-dos, I'm going to write for coming USB 3. I hope then become the first to meet USB 3 in the presentation world. In conclusion, I will summarize the main points. PVUSB reached at the level that any user can use. Now PVUSB has maybe user-friendly interface and correctly working hardware. PVUSB will provide flexible and high performance if the device is sighted. And as you see, various device working against the main. I'm getting over.
So I think if you have questions, because we're running a little late on time, I think if you have questions for Noboru, maybe you can step outside for a second if anyone wants to talk to or attention later. So we'll do it that way. Okay, thanks. And next we have Teo Ma from Oracle. I apologize.